everyone else, but I also muted myself. Wait. Now okay, but I want to check whether or not I have muted others. Huh? Okay, this is what I clicked just now, so that others don't suddenly make noise. But that means, oh, okay, now I don't do this. Okay. Can you all still hear me? Yes. Okay. Okay. So, okay, so I repeat again for those online, sorry, very quickly. So essentially, all exercises will be due in the next week thereafter. The first week, you will spend to discuss with your TAs, right? And if you want to submit earlier, means on the day itself, you can also submit on the day itself, right? So that we are able to please both ends of the metrics, right? So those people who are already quite comfortable, they can submit their assignment and be done with it and move on. Those who are not will have more time to practice as well as to check with the TAs. And with that, you will have more contact time with the TA and therefore will have less issues about you misunderstanding the TAs, not giving your time and asking you all just to go and Google it. Okay, so that is for the exercise. We have also have other feedback regarding the content. Okay, so there was a request for Kangaroo, so we are going to do that later on. Okay, Kangaroo is a physics simulation engine. There were also a request from landscape architecture students to learn about how to create a site from points. We will also do that later on. Okay. There were queries, why do we need to learn Rabbit Dynamo if we already know Grasshopper and there's Rhino inside Rabbit? That is true, there is Rhino inside Rabbit, but it may not be true that when you join a firm next time, they have Rhino. So there's no point of you knowing Rhino inside Rabbit if the company that you work for doesn't have this software. Okay, so if we bring back to the first principles of this module, right? As I've told you in the first lecture, this is not meant to be a software lesson. It's meant to teach your spatial computational thinking. And in a nutshell, an introduction to parametric design in general. So how you will be able to take complex designs and simplify them to their first principles. Okay, so this can be applied to any software. It could be Grasshopper, it could be Dynamo, it could be generative components. And why we want to still have one lesson, one teeny little lesson, is so that at least you know this exists. When you go out for your internships, when you go out for your careers, and you will know how similar it is to Grasshopper so that you can pick it up efficiently during your internship or during your careers. Okay. Okay, so that is that. Then, of course, finally, you all have all requested for the lessons to be slower paced, right? So 50% of you say it's okay, but another 50% say that it's too fast. So I also understand from the Singaporean mentality, right? If you don't want to raise your hand and say, oh, can you repeat that? So we will go very slowly, and I'll try to really ask specifically how you all are doing. Okay, so if say for example we cannot finish the kangaroo part today, we will carry it on next week, because if you are to look at the exercise, the exercise has said that you may or may not need to do the kangaroo as part of your exercise. It's an option 2. Option 1, which will be just to use any design and then apply the data management skills that you'll be learning later on. Okay, which will be here onwards. Okay, so you can also apply this slide of how you connect things to our earlier Esplanade tutorial. Okay, and here this is the part that I've adjusted to have a landscape application, how you can generate a mesh site from a point cloud. Okay. This also does not mean that our feedback, is like a two-way process. It's not I'm prescribing to you what you should learn. You can feel free to tell me what you want to learn, and then I will incorporate it to the curriculum. So if at any point of time you still want to contribute to the so-called quiz, the survey, you can feedback to your TAs, or you can email me directly. Okay, so the process does not end since 2 weeks ago. Okay. Okay, so to make it visually interesting for you all, this is what you will learn at the end of the lesson. This is a kangaroo simulation, right? So essentially, you will learn how to do this kind of simulation, form finding exercise. Okay. Physics simulation means that it will just react to the physical world elements, for example, gravity, simple forces. Okay, we will share with you how to do karamba later on. Okay, that is a more precise structural analysis tool. Okay, so for example, now this is a parametric system. I can move this angle to say here, and I can reset the analysis, not the simulation, so to say. Okay, so this can be useful for landscape design students, right? You can make like a nice slope design. We can always reverse the direction and make it positive so that it becomes like a structure instead. Okay, maybe this is too strong. Yeah. And you can see this kind of interesting results. Okay, so you can reset the simulation again. Okay. And towards the end, you can really directly make this into a architectural element. So if I were to enable this now, so you'll be able to see the structure. Okay. Okay, so this will be the completed structure based off on your analysis. Okay, so something similar to what we have learned from the Esplanade cum Jewel lesson, right? And then that is the end result of the lesson. But the first part that we will go through very patiently and slowly as requested is the data management. Because for example, now we have created so many pipes and structures, right? So how are we going to manage them for fabrication, for data? Okay, my computer is hanging because there are too many elements. Let me just disable it quickly. Okay, so now it should be faster. Yep. Okay. So the first part of our lesson will be about the data structures. Okay, how to generate a series of points, and then after that, read and write and create a list of points that will generate our landscape over here. Okay, so during the hands-on in around few minutes time, we will create a rectangle. We will make the rectangle a mesh, export the XYZ values to it, and then after that, use Excel to randomize the heights of the points. And we will read these new values from Excel into Grasshopper and then create this mesh. So why am I doing this roundabout way? Because you may have your XYZ values from somewhere else. For example, you have it from a point cloud that you receive from a surveyor, right? So you can ask your surveyor to give it to you as a CSV file, and then you can directly translate that into a terrain in your Grasshopper or Rhino model. Okay, clear? And in the meanwhile, I'm also teaching you what I've always wanted to teach, which is data management. Okay, and what do I mean by data management? That means, for example, being able to merge the information together. In this case, this is a possible application for your exercise. I will not run through this because we don't have time. Okay, but this is how you can, for example, take the Esplanade tutorial, use the aerial tool to calculate the areas of all the sunshade panels, and then merge the information in as a series of lists, and then concatenate the information. Concatenate means that you will splice the information and insert another information in. Okay, so say for example, this is the difference between merge and concatenate. You may not understand it now as I explained to you, but later on during the hands-on, you should be able to understand. Okay, merge means that if there's 3 streams of data, they will be added following each other. Okay, where you concatenate between A and C, fragment B here, in this case, the information is C and D, it will splice through whatever there was this, the first one of A and the first one of C. So A and E, right? A and E, and then you have this in the middle. Then the next one will be B. So you will splice in again CD, and then EF to F. So it's B and F. B and F. Okay. This one is a bit too abstract. Later on, during the hands-on, you should be able to understand. And then after that, we will teach you how to generate an Excel sheet from the CSV file that you will create from Grasshopper itself. There is a plugin called Lunchbox, which automates this for you as well. But as I've been saying before, we teach you the fundamentals so that if you don't have a plugin, don't have access to a plugin, you can still do it from vanilla Grasshopper. At certain times, when you go to other firms, maybe they do have Grasshopper, but there's a system administrator issue to download plugins, right? That's very common in large firms. So to circumvent that, if you are able to use the vanilla installation, you can still operate as it is. There are other plugins that are available, for example, Bumblebee, but this is not supported recently. I think he has moved on with his life. As of now, I think it only supports up to Rhino 6 version. So when you use it in Rhino 7, it still can be done, but not so smoothly. There may be some bugs. Okay. So you can go to the module. So it was my bad. I didn't publish it. I always have this very bad habit of posting it and then not clicking on the publish button. But I have just published it like at 9 a.m. Very sorry. After one of the students asked. Okay. So you can download the PowerPoint as well as the Grasshopper file as a reference while we go through this from scratch. Okay. So we have a new document. And just make sure that in your Rhino file, your units are in meters. Okay. So type units and then meters. Okay, I can delete all these points first. Okay, I repeat again. So today, as for the feedback, I'll be very slow. Type units, make sure that meters is selected, and click OK. Okay, everyone have this? Okay, now we move on to Grasshopper. Okay, double click on the canvas and type rectangle. Rectangle. Choose the last icon here, where it shows a black border around an orange color square, even though it says rectangle. Okay. So you click on that button and you will see this come up. Okay. It needs a plane. The default plane is already the XY plane. Okay. What we are going to do now is we will change the X and Y size. So I will just input 30 meters, 30. I will double click on the canvas as I've done just now and connect it to X. Oh, I forgot about the giant cursor. Sorry, cursor. Okay. Okay, so you can see exactly. So we have 30 meters to the X direction, and then we have 60 meters in the Y direction. So just double click, press 60, and then you connect. Okay, I will zoom out. And now you will see a rectangle that is 30 meters in X and 60 meters in Y. As I've explained before, we are just creating a generic rectangle and a generic mesh from the rectangle so that we can export. Oh, why you frown? Don't frown. Girl, don't frown. You get wrinkle. Why you don't understand? Too fast? Huh? I'm really trying my very best to be very uncle-ish and slow while not making you sleep. Oh, okay. Can. Okay. She was frowning very intensely, like questioning why the rectangle must be 30 by 60. Okay, so everyone have rectangle now? Okay, we are going to mesh plane. Okay, create a mesh plane. There's two things. Yeah, this one trying to catfish you. No, don't choose that. Choose the second one. Okay, without the vertical thing in between. Okay, so this is the mesh plane. What you need to do now is to connect the rectangle to the boundary, right? And this allows you to calibrate how many meshes, subdivisions you want within the width and the height. Okay, so I'm just going to be lazy now. I'll move this down. And I connect this, the same X to the same width, the same Y to the same height. Okay? Can? Okay, I repeat. Double click. I type mesh plane. Don't choose this one. Choose this one with the orange rectangle. Then you connect the rectangle here to the boundary. And then the same X to width and the same Y to the height. Okay? Can? Everyone okay? So same thing, like throughout the semester, your TAs are your friends. You don't know, you just raise your hand. Then they will come to you. Okay? Okay, so now what we are going to introduce to you is this command called deconstruct mesh. Okay, over here. I'm just going to leave this here. It is very similar to the same concept that we told you all before for the Explanate tutorial, the deconstruct BREP. It's just that it's a different geometry, but you are still deconstructing it. Okay, so click on this and connect your new mesh plane to your deconstruct mesh. Okay. So if you were to zoom in now, you will see essentially that whatever is there on the mesh plane is now on your deconstruct mesh in terms of the vertices. It has divided it by 30 divisions here and 60 divisions here. Okay, in 1 meter intervals. That's why you see my grid here is 1 meter. Why? Okay. So, why we want to do this thing is because we want to just get XYZ points. I've just created a panel and connected it to the vertices. Okay, so now this is giving you all the X, Y, and Z values of each of the points that we have generated. So the first thing here is X. The second thing here is Y, and the third thing here is Z. Okay. In fact, with this, right, you can already export to CSV file. Okay, what does CSV mean? Okay, it means comma separated values. Okay, computers before the advent of AI, or some people will contest computers are still stupid because there's a fixed rule set that we are teaching them. So same thing. So for comma separated values, right, the computers will just see if there is a comma. Then it will separate the data that is between on each side of the commas. Okay, that's why we mean comma separated value. Okay, so this now in this format is not as useful to us. And I will just show you a negative example. I'm going to right click now. And then I will choose stream destination. Okay, what stream destination does is that it will only define to Grasshopper where you want to create this file. Okay, I'm just going to put this as today's date. 306. You can put it whatever date you want, but make sure that you change the save as type to be CSV. Okay, CSV. And then you save. Okay, but this does not create this new file now. Okay, it does not exist here in this folder that I've just said that it will. What you need to do is you have to still do this next step, which is to right click and then stream the contents. Okay, now I click here. If I were to go back over to this, you will now see that my CSV file has been created. So within a very quick 5 minutes, right, what you all have done is you have already done some data manipulation, no, data management, because you exported a data file. Okay, when you double click on a CSV file, Microsoft Excel will naturally detect it as a CSV file and separate all the commas into the columns. Okay, so now when I double click on this file, you can see that it has exported the information. And why I say this is a negative demonstration, because if you were to scrutinize, the values for the column A and the column C over here are not so right. You will see that there is a curly bracket. Because, as I told you, the computer is strictly by the book. Whatever that is on the left and right hand side of the comma, it will separate. Okay? If it's a curly brace, it will also separate. It doesn't know that this is just a bracket to contain and separate the XYZ value of a particular point. So this is where we need to do some data management, data sifting, and data splitting. Why? You got a question? The one standing up? No? The TAs are here at the bottom right hand corner. Okay? At any point of time, if you are confused, you can go back to the file here. Right? It's on the top. Okay? My data management part is on the top here. Okay? From this end onwards, deconstruct mesh, then we will deconstruct the vertices instead, the point to XYZ, and then we will concatenate, we merge, and then we will then read the file. Oops. Okay. Okay, I go back here. Okay. Everybody okay? All have this CSV file? Okay. So I'm going to close this now. Okay. And then I can move it up. So we already say this is a negative demonstration, right? So we want to convert it into just the XYZ point. So to do that, what we will need to do is the point deconstruct point. Yeah, this one. Deconstruct a point into its component parts. Okay, you click on this. And then now you connect. I will just open a panel and connect this here. So now you will see that you will take all this first X value, and then if this is Y, this will be all the Y values, which don't increase, as well as the Z values. Okay? Can? So now this information, right, we need to label it, correct? Because, for example, if you create this CSV file, you may forget what are these values, what are the first column, what is the second column, what is the third column. Okay, so you will need to create a header for this. So I'm going to make a panel, and I double click, and I just call this X, Y, and Z. Okay, and then click outside. Don't press enter, because when you press enter, it will make it into a new list. Okay, people are squinting. Let me see how I can fix this. Okay, can see? Yes. So this will be the headers over here, later in the CSV file. Okay, and we have to go back to this thing that I also admit is confusing in the first place. But now it will be able to shed light with this hands-on. We are going to concatenate this information in. Why are we concatenating? Even after we split them up into X, Y, and Z, this whole exercise is to remove the curly brackets. Okay. So now I have to add my comma back in again. So I will concatenate. C-O-N-C-A-T-E-N-A-T-E. So you click here. So this is my fragment A, which will be my X value. I'll create another panel. Okay, never mind. I will just copy and paste this so that this will be a big font. And I change this to comma. And I click on the outside. Don't press enter. Do not press enter. I will reduce this. And I'll put this here. Now let's see what happens. Okay, I just show you. I create a panel. You see, it will add a comma behind every value here. Understand? So this is what concatenate does. Now, you can zoom in to your concatenate. Then you can click on this little plus thing. You will add in another input. Okay. So I will connect my Y over to here. Do you notice what has happened now? It has added the other column of values in. Okay. Then now you zoom in and you add plus again. Now I just want to connect. I zoom out. Okay. I also need a comma here, right? After my Y column. Makes sense, right? So I will use my same comma here and connect to this. And you notice what has happened? He has added another comma here. Okay? I will wait. I will look at your body language. See whether anybody is confused. So if you're shy, you can give that. Look. Then I will send the TA there. Don't suffer in silence. You pay thousands of dollars to come to university, not to suffer in silence. Okay? All okay. So now I will zoom in. The next step is quite obvious, right? I will add another input. And I will simply need to add my Z as a column in now. Okay? So now you get what we wanted. Right? without the curly braces, and I'll move this here. Okay. So what is happening now, and just to let you all understand about data structures in Grasshopper, right? Do you notice this funny thing here, 0, then semicolon 0? By default, Grasshopper always tries to make this into two branches, so to say. Okay, this may be a bit abstract. I'm going to use this thing to show to you. Double click on the canvas and type param viewer. Later we will come to this when we have more data. Okay, so you should see this thing. Connect this over to here. Okay, so this is what I mean by data with one branch. By default, I'm just going to make it even more visually appealing. You right click and you click on draw tree. This is what is happening. Okay, by default, Grasshopper always try to make your data into a tree, data tree. There is a branch for this. But technically, you don't need to have this as a data tree. When you right click and simplify, this thing will still be the same. Okay, because this is already in its simplest form. Later on, when we go to more complex data structures, you will see this portion becoming really like a tree, let me scribble. You will see things like this, and this, and then another data. And then from here, it can even branch off to further data. This is especially true for our Esplanade tutorial. Because our Esplanade tutorial, you will realize, remember the time when I show you all the example, we focus on one item in the deconstruct VREF. And then when I overwrite that, then the whole surface is proliferated with the sunshade. It's same thing. What we have done for that example is we focus on one part. Once you finish for this, all the branches will be applied to. Okay, this one is still very abstract, but never mind. We will come to that later, and then you all will be able to understand visually. So why do I show you this? Because now what is happening is there is one stream of information here and one stream of information here. We want to merge them together. Okay, so we will use the merge merge data stream. So use this last one over here. And then I will click. Okay. So you will merge this one with this one. And then now let's observe what is happening. I just copy and pasted this panel and show you what is the new output. So you can see here now, there's one data stream here and another data stream here. They are organized in a different way, but when I put this inside here, right, it still is to the same division. Because to grasshopper, 0 is the same as 0, 0. Only when it's 0, 0, semicolon, another 0, then it has branched off. Okay. And now you will also notice something very peculiar, correct? Originally, our wires here are single line. Now, they become this dash line. Okay. If you don't see this, that's probably because you don't have draw fancy wires turned on. Okay, you can click on this and you will have this. So this is with fancy wires turned off, and this is with fancy wires turned on. This is just to let you as the computational designer understand what kind of data is coming out from each of the components. Okay, so this is when there is already a certain form of data streams, right? There's two streams of information. If you see here what I've just done, I right click and then I flatten. Can you see here? Okay, sorry, must make it like a action replay. This one line, correct? No branch. I right click and I unflatten. I zoom in. There is a branch. So that's why you see this is with the dashed line, right? Because this is a branched data stream. Okay. Okay, this may be a bit abstract to all of you, but let it sink in your head. I will not insist that you all will know this, but just understand that Grasshopper tries to organize information into branches and trees. Okay, I'm just going to flatten this now. Okay, so now it's all neat. So you have this and you have this. Okay, so then now what I'm going to do is I will right click and I will do stream destination. Again, I want to create a new file. So I will just call this today's date. And then I will type X, Y, Z. You can name it whatever you want. Okay, I'm just putting it as X, Y, Z. And same thing, remember to save it as a type CSV file. Then we save. Okay. Oh, it auto changed this. Dash X, Y, Z. Okay. So as you all know, I repeat again, it will not create it first. You are just telling it, I want to name it this way. But you still have to right click and stream content again. So stream content, and then now you will see this. Okay. Then you double click. And now you will see this is cleanup. No more brackets meshed in together. And you even have the headers here. Okay. So effectively, what I've just done is I've taught you also how to do this. Okay. So there's a lot of labels that you can put. Instead of putting it as XYZ in these notes that you see here, we can call this panel 1 area, panel 2 area. for the explanate tutorial or the pipe length information like this. Okay, but today I'm going to benefit the landscape architecture students more. Okay, so now that we have all these x, y, z values here, okay, I'm going to simulate a situation, correct? For example, when you get a survey file, right, a terrain file, it's not going to be flat consistently, right? Nothing is consistently flat. So I'm just going to use Excel to randomize the numbers. Okay? to simulate, for example, you receive a point cloud file or you receive a survey information with platform levels. Okay? So what I'm going to do now is I'm just going to go to this. Let me just zoom in so that you all can see. Over here, I will make it into a formula. Okay, I will press equals to RAND random, and I want it to not be any random number, right? Because otherwise my site will be like my blood pressure that go up, go down, go up, go down, go down. Oh, so I will put it as rand between. Okay, and you have this bracket. So you'll be between the lowest number. So if we think about it from the 3D point of view, right, our lowest value will be 0, correct, where it's on the plane. And then our highest value, let's just say it's like 3 meters, right? So from 0 to 3 meters. Okay, and then I press close bracket and enter. Okay. So what has happened is that this is still a random number. It's just that it's randomizing it at 0. Okay. And a trick for Excel, right, to copy your formula is simply, there's this little black dot here, this black dot at the bottom right-hand corner. You click and you drag all the way down to the end, and you will replicate it for every single one. Okay, here, to 1892. Okay, and then you release. So what has happened is, it has applied this formula to every single row of this column. Okay, and that's why you will see here that it has already automatically generated to you different values from 0 to 3, even within this Excel. Okay, so the whole point about this is I'm just teaching you a way to create new values for a CSV file so that we can read these values back into Grasshopper. Okay? So now what I'm going to do is I'm going to file and I'm going to save as. So I'm going to save as dash XYZ dash random. Okay, so this is my random XYZ file. And then I save. And you say yes. Yes, I still want to have CSV file. Okay? Yes. Okay. Action replay. Can I go back? I Control Z. Okay, so here, this is the formula where you type. Okay, can you see? Do I need to, how to magnify? Oh, I know. Wait. You have to type in this RANDBETWENN. Then this first value here is the lowest value, which we are putting at 0. Okay, and then the next value after the comma is the highest value. So we just put it as 3 for now. Then we close the bracket. Then what I've done just now is, this is my formula done on this particular, what's that thing called? Row. You see this little corner here, right? When you move your mouse, you see my mouse is very big, right? Fat. It's a fat cross. When I go here to a slim cross, then I click and then I drag all the way down. Left click, then I drag all the way down. Until the 1892. Yeah, until here. Then the very last list, right? And then you release. Okay? And then you will see all these values already randomized. If I can do it with 2 fingers on my trackpad, you can do it with your mouse, for sure. Okay, everybody has this? Can anybody confused? Everyone has a CSV value with different Z values now. Okay, let me check the chat. What is GWS? Why? Oh, maybe I'm just coughing because I'm too slow. Okay. TKS student. Okay, let's go back. Okay, here. So we have this already, right? All have this. Now we want to read the information back. It's the same thing. In the notes is here. I will teach you why this is red now. Because whenever, okay, Grasshopper is written in C#. And C# is like a variant of C that is for Microsoft based programs, like Windows based programs. So it also means that if you have like a Excel open at the same time when you are running this, it will hang or you will have an error. So just always make sure that you close your Excel before you read or write information. Like just now, you see when we write the information, right, there was no Excel open. And now if I want to read the information, I close this. I've already saved it before, so I just click don't save. Then I will read the information. Okay. So now what I will need to do is I need two things. I need to read my file. Okay, some of you will not see this. This PG and XML things are from the Lunchbox plugin. Okay, if you have vanilla Grasshopper, just use this read file. Okay, read file. And the next thing that we need to do is file path. So if we want to read a file, we need to tell Grasshopper what to read from, right? So click file path. Okay, and then now we will connect this over here. So we need to tell it where this file is from. So you right click here and you select one existing file. And you will choose your random file. Make sure your Excel sheet is off. Otherwise, you will see that it's red. So click. And that's done. Now, I will create a panel and I connect this. Oh, no. Let me just use the same size so that you all can see. I just copy and paste. Okay, so now you can see you just have a basis for comparison, okay? What we started off with was our flat plane of values, correct? I go to Excel and I change the information. You know, it's like money laundering. You go take this, then you change the location, and now you have a brand new set of Z values from Excel. Okay. So now I have all these nice new values here. And what we need to do now to make it into points, right, is we have to take out the XYZ again. So it's really kind of like, if you use the analogy, it's like you're trying to launder the money. You go and put it on the crypto exchange first, then you change, then after that you put it back into dollars again. Okay, so how do we do that? We will split the list. SPLIT LIST. Okay, you split the list. So I take my list over here and I need to split it. They will ask you where to split it at. Okay, so it's very easy. I want to split it from here onwards. Right, this is my first item. Again, another reminder, right? To Grasshopper, it starts counting from 0. So I want to split it at index 1. 1. I just press 1. Okay. And then I connect this here. And I copy and paste this. And I check. So this A is the one that you split off from. And this one is what you have. Okay, so I've split off from the first index. So that's why the XYZ is in list A and the rest is in list B. Okay. Some of you may question now, wow, Prof, why you spend 1 hour and 10 minutes doing the same thing again, just to change the values. But this is just the fundamental techniques, right? How you auto-generate values, how you merge the value, export it out, and then from there on, you can do whatever you want to do it in Excel. Okay, or you can skip the first step. You already have the Excel information. When you read it in, you will know how to adjust this information, remove those that you don't want, like the headers, and just give you the content over here. So that then now you can take these values and create your point. Okay? Clear? All have this now, right? All back to square one again. Okay? Now, the next thing that we will do is we will text split. Okay? TEXT SPLIT. So it's really exactly the opposite of what we did with concatenate. Okay, so I will push in my text over here from my list B. And my separators obviously is my comma, right? So I just go back there and copy my comma in. Control C, Control V. And I move this in here, connect this in here, sorry. And now let's see what has happened. I'll Control C, Control V again. And let's see what's the result. Okay. So the important thing here, right, is that you can see that the good thing is the Grasshopper is storing it into their own packets. So even after you have split it away, they are still in their same packet. This is a verbose way of Grasshopper when you start off with one simple index. After you split, right? So same thing, you know, just now you have a tree, you branch off. When you change the tree, you split the tree, it will auto create another branch. That's why you see from here, it becomes like this. But regardless, right, they are all still in their same packet, which works well for us. Because now, what we are going to do is we are going to use our good old friend, the list item, right, to extract the first, second, and third value of each of these packets. Okay? To put back in to construct a point. Okay? So before I even go there, I just type construct point. Okay? This is the command. It's called construct point. The construct point needs a x, y, and z value, which will be this x, y, and z value, which is actually from here, right? Let me just scribble again. So this guy is the same as this guy. It's just that you took away the commas. And now you want to make them go individually here. Okay, understand the logic? So we will therefore need to use the list item, our good old friend here, and connect this here. Okay. I will again just use this to show to you. Okay. Once I have done this, you can see here that it will start this 0, 1, 0, 1, 2, 3. You will take the very first number of the sequence. And now this is the part where I will show you something further to our good old friend, which I have not shown you before because I didn't want to confuse you. But today I will confuse you. I will zoom in here. See? You can see that your items, right? No, last time I always show you, you copy and paste. You have one for every index. Because you will label the index here, right? Now that I see that you all understand that concept already, you can press plus here. And what has happened, right, is it will take the original index. Here by default, I hover here, is 0, right? The next one, when you plus here, will be plus 1 of the original value. So that will be 1, and the next one will be 2. So this is useful when you got a lot of spaghetti, like your grasshopper code, you have a lot of things ready, right? So when you are confident next time, you can do the Esplanade tutorial and you can split, deconstruct the BREP, get the vertices, and use this as 0, 1, 2, 3 for all of the 4 points of your deconstruct BREP. So therefore, with this logic, I just connect this to X, this one to Y, and this one to Z. And you will get all the 1,891 points again. Why? Because the first row is XYZ, even though there was 1892 values. So I go back here again, and then you will see this is your beautiful new set of points. Okay. To make it neater, hello. Okay. I'm just going to hide everything else. Just select all of this. Oh shit, I don't have middle mouse button. Aha. If you all have middle mouse button, you all can hide. I will just hide them manually here because I didn't bring the mouse. Okay, so I guess, yes, so this will be my new randomized points from my CSV. Okay, so it's like, you read the newspaper, got the money laundering, right? Nobody will know where the points are from because now they're all randomized. Okay, but what we are going to do is we are going to make this into a terrain. Okay, so with all these points, because originally this was from a mesh, right? The mesh was constructed, right, with a width count of 30 by 60 mesh plate, right? That is flat. Since now we have a lot of three-dimensional points, the most efficient way to create a mesh out of this is to use a Delaunay mesh. Okay, this is a mathematician who found out this geometry, okay, of triangulation. So just type DELAUN. It's like money laundering. DLAUN. Okay, click here, and you connect the points. Okay. And it didn't work just now because it was still into its convoluted data structure just now, right? Because everything was stored as a packet. So when you try to create a Delaunay mesh, it will just be creating a mesh out of one point. You need to flatten it so that it becomes part of one entire list. So what I did just now was to right-click, flatten, and connect it to the Delaunay mesh. So ideally now, wait, okay. I will hide this and I will see this. Yeah. Okay, so this will be your mesh. Okay. So you see now this is a bit like cranky, right? Doesn't really look like a geometry, but this is just to show you the extreme examples, right? I can always go back, right? I go back to my XYZ random and I can change my formula, right? So now I'll just change the formula to equals to ran between 0 to, let me just make it more conservative, to maybe even 1, right? So you'll definitely be quite smooth. Enter. And then now I will just drag this on for all the other values. I purposely do this so that it's also a negative demonstration for you to show you that the file will, I'll save this, click yes. You go back to your grasshopper and this guy will turn red. Why? Because you cannot read the file as you have the CSV open. Okay, the Excel sheet open. So once it's closed, you just need to right click and recompute and it will work again. And then let's see. So now you can see that this is less crazy already, right? As earlier on. This one really looks like a site for your landscape architecture. Just now it was more zigzag, right? Now it's only from 0 to 1. Sorry, 0 to 2. Okay, so don't go home and tell your parents your professor teach you how to launder information. Okay, this is just to tell you how to manage your information. Okay, you created a rectangle to generate a mesh. From the mesh, you got points. You go out to Excel and then you clean up the information in Excel. No, not you clean up. You adjusted the information in Excel. You brought it back to Grasshopper again. And with this information, you created a new topography. Practical applications could be that next time you get a point cloud values for landscape architecture students, right? You can take all these heights and apply it according to the spacing in your grasshopper file, and then you will generate your terrain already from the points. Okay? Okay, everybody clear? All clear? Okay, so to relax, right, I will show you all a video. Then those who are still not so sure can relax and watch the video. Okay. We are going to move on to kangaroo, but before we move on to kangaroo, let's just relax with this video. Because just now the funny thing that we did, then you fall down from some balls and then you create this fancy structure. It actually makes sense because
in this video, we explore arches and chains. Arches are popular and beautiful structural components. You know where to look. You can find them in bridges, buildings, tunnels, wells, dams, and many other places. Chains are also used widely, and they can be found in lifting equipment, playgrounds, and many other settings. As we will show, close parallels exist between arches and hanging chains. And since chains are easier to understand, let's talk about them first. Consider two chains side by side. One is light in weight while the other is heavy. As you can see, the weight of a free hanging chain does not affect its shape, but the spacing of its ends does. Each shape in this family is called a catenary, and each catenary is similar to a parabola. If we add external loads to a lightweight chain, its shape changes considerably. What do you think will happen if we add the same weights to the heavy chain? It turns out that those weights have little effect on the shape of the heavy chain. Chains are often referred to as tension systems because each of their links carries tension. Notice that no bending forces or moments are transferred from one link to the next. If we make a mirror image of a hanging chain, we get an arch. In an arch, the component pieces push against each other, unlike chain links which tend to pull apart. To ancient builders, this represented a huge advantage. If they placed a bunch of stones in just the right positions, they would push against each other and stay in place. This made for structures that were both simple to construct and highly durable. Here is another difference between chains and arches. Because chains are tension systems, they automatically reshape to better carry whatever load is applied. Because arches are compression systems, they do the opposite. So if they are not shaped appropriately for the loads they are asked to carry, they can collapse. As a result, designers must tailor each arch to the loads that it will need to carry. And how did we figure out the shape for the arch? That was easy. We just hung it upside down so that it worked like a chain system, applied the loads, and maintained those angles when we turned it right side up. In the late 1800s, a famous architect by the name of Antoni Gaudí used exactly this technique to design the arches of the famous Basilica of the Sagrada Familia in Barcelona, Spain. To figure out how to shape the arches, he built a precision upside-down model of the basilica. His model was like this chain model. It changed shape as he added miniature weights corresponding to the loads of the roof and other features that the arch had to support. The resulting final profile showed him the exact shape to use for each arch. In many real-world structures, the weight of the arch.
So that's cool, right? Okay, I repeat again. Okay, so this thing, okay. So this guy in the 1800s, he used this technique that was developed 200 years ago in the 1700s to design this building, which is still under construction, by using this mock-up.
Upside-down model of the basilica. His model was like this chain model. It changed shape as he had miniature weights corresponding to the loads of the roof and other features that the arch had to support. The resulting final profile showed him the exact shape to use for each arch. In many real-world structures, the weight of the arch is much.
Yeah, so that's exactly that. So you just need to flip it up, and it will definitely resolve the weights. Okay, and that's what we are going to do next for the kangaroo example. Okay. So we will use the same mesh over here as well as the deconstruct mesh from this part on. Okay, so the rest of this, right, actually from here onwards, I don't need to use for now. This one is just for the data management part of the lesson. I'm going to right click and I disenable. So the difference between preview and disenable is once you do this disenable, it will not do anything. It will stop it. It's like when you have a river and then you dam it up. That's what it does. So same thing here. I also don't want to read any information. So I right click and then I disenable. So all of this stops functioning from that point onwards. I'm gonna move this down. Okay. Okay. So just so that you can visually see something, I will. Okay, what I've done is I disenabled the rest, right? And now I focus on the mesh plane and the deconstruct mesh. Okay, we are going to use this mesh to simulate the same experiment that Gaudi did many years ago for this. Last time, they had to construct this manually. Now you have the benefits of using a digital model. Okay, so you just imagine all of this, right, as a mesh. All of these weights are your mesh points. So I will right click here and I will preview. Okay, so these are all my mesh points. Okay. Now what we need to do is, remember from the video, right? We need to anchor. These are the anchors here and here. These are the anchors, right? So we want to tell Grasshopper where to anchor from. And I want to do it interactively. Okay. So I will go here. I will create points. Okay, I use this button over here. I click this and I'll just draw a few points. One here. One here. I don't know why I cannot move this. It's like stuck. Okay. So I drew 2 points here. Okay, I'm going to draw another point. Another 4 more points. So I'm going to click here, point. Click here. 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 And here. So for a total of around 6 points. Generally in this location. Okay, so use this tool to draw 6 points. This will be the points where we will be anchoring our model. Okay. So firstly, I want to go to Grasshopper and tell Grasshopper that these are all my points, right? So I will double click and select the point tool, P-O-I-N-T. Everybody have point now? Everybody have a lot of point here and then one point thing here. Have, right? Now you just need to tell Grasshopper by right clicking and set multiple points. Okay. So I'm going to set all of my points here. And then press enter. Okay, so now you will see that this Grasshopper is generating, is connecting to Rhino via this point. Can everyone have this? You should see a sea of red points and then 6 points here that you have just made. Okay, so now what we're going to do is these points, right, are just reference points for us to grab some of the mesh points for them to be the anchors. Because I don't want to just have one point as an anchor, right? It will look very weird. I want to have a series of points here. So the analogy is that if I were to just go back to the example here very quickly, then you can see. It's creating all these spheres. That hold onto the points at this point. Okay, to create this reverse catenary model. Okay. So you understand why we want to create spheres now? Because if not, if it's just one, it will look very sad and weird. Okay, but you can experiment with it later on. Okay, I'm going to go back to our hands-on here. So that's why we have this. And therefore, we want to make the sphere, the point into a sphere. Okay. So type sphere, S-P-H-E-R-E. So my base will be all these points. And my radius, I can set it up to be however big I want. I'm just going to make a slider of 5 and connect this over here. Okay, so then this will be my radius. I can increase the sphere later on, and you can play around with the simulation later on. It'll be quite cute. Okay. So what we want to do, right, is to tell Grasshopper to pick this information from all this list of points, right? I want to separate from those that are inside the spheres and those that are outside of the spheres. Okay? So we will use the point in dweb tool. Okay, point in dweb. So our dweb will be the spheres, right? The ones that are covering them. And then the vertices are the points here. Are all the points that you want to test for. Okay? And what it gives you is true or false. It will tell you whether they are in the BREP or not. So if it's not in the BREP, you will say false. If it's in the BREP, you will say true. And this is again called data management because we are going to use a command called the dispatch command. Just now, our split list command tells the computer specifically from point 1 onwards, this one, this side, the other one, the other side. Okay? But for dispatch means that it will take whatever that is true in the first list, whatever that is false in the other list. Okay? It's just the same as like this whole LT, right? I can either say from the first row onwards, all get A. Or I can split into boy and girl. Girl all get A, boy all fail. Okay? Understand the difference now between dispatch and split? Okay, so now what we will use is dispatch. So you type DISPATCH, dispatch. So of course, naturally, we will need the list. And we will need the pattern, which is all from this point in BREP2. And we want to visualize the difference between these two lists. So I'm just going to create a point container. So I just double click and type point. And I have this guy here. Control C, Control V. And I'll have all of this here. Okay, so I have grafted the information here from the sphere onwards to make sure that the list here for the points are correctly distinguished. Okay, so previously if I didn't graph this, I right click and I ungraph it. It's only taking the very first sphere, which is strange. Right, by right it should be all of these points. I can try this also. No, this one doesn't work. So never mind, I will just right click, unflatten, then I will graph this. Okay, so then you have these sets that will be our anchors. And then these ones that will be just the rest of the list. Okay. So for our kangaroo, what we will need to do is we will need to establish your anchor, and then you will also need to get the edge length as well as the naked vertices. Okay, so what we need to do now is we will use the naked vertices tool here. And we must connect this to the original mesh. Okay, so let's have our original mesh here from this make plane here to here. Okay. Let me try this without grafting here. Okay, I'm going to right click and graph it again. And I use my naked points instead. Yeah, I think this is better. Okay. So I'm just going to move this aside. Okay. So now we are just going to concentrate, instead of having all those here as a clump, I will take the naked points here. Let me just visualize for you with a point tool. So you see here, by using the naked vertices, you can isolate the points on the edge of the mesh. Naked means that they are not connected to another mesh point. That's what they mean by naked. Okay, so I'm going to connect this here now. And what is happening is with my points here, I create my sphere, and I will check whether or not they are within this naked list of points, all this, and get these guys and these guys. Okay, so you have a set of points now, similar to here, set of points here. See, it's from naked points to the point in B wrap. Okay. So our next step, right, if you see from the reference command, is those are where we will point to as the anchors. But we also need to apply the loads, the edge lengths, and then we use the same analogy that we did before, which is to merge all these values in together for our hands-on over here. Okay. So I'm just going to create the anchor now. ANCHOR. And choose anchor. Anchor XYZ is when you are more specific about how you want to fix your points. For example, if you use anchor XYZ, you can choose to anchor it only in the Z direction or only in the X direction. For us, we will just anchor it to every direction. And I'm just going to make it to the anchored points here. And my strength, I will put to 75. You can play around with the values later on. Okay. So this is the anchor part. Okay, so we have our anchors. And then we will need to use the edge length. Okay, set the edge length of a mesh. So you need the mesh. Okay, so your mesh will come from the original mesh that you have over here. Mesh plane from the mesh plane. So I'm just going to connect it and move it here. Okay, to make it easier, what am I going to do is I will just make it into a put it into a container so that I can push it everywhere. My mesh here, push my mesh here, and then now I can move this all the way to here. And I can connect my edge length to the mesh over here. My length factor, I'm going to put it as 0.15. This is just an arbitrary number. You can change it later on. And you will notice the difference in simulation. Okay, strength-wise, you can keep it as the default value. Okay. Then the next thing that you need to do shall be the loads. So this is the one over here, load, L-O-A-D. So you need all your points because you need to load all of this. All of these points over here. So we go back to this one from the, so it should be the original points. which is all of your vertices points here. Okay. To connect here. And for the force vector, we will put it in the z direction because that's the up direction. And I'm going to create a slider from minus 0.9 to 0.9. Because the units here are always in kilonewtons. So this will be negative 0.9 kilonewton. So that will be the downward gravity force. Okay, then the last thing that you need to do is to show the mesh. This is just a kangaroo element, which tells kangaroo that you want to show the mesh geometry after you have done the simulation. So connect the mesh to show over here. Okay. So you have all these 4 elements here. We will repeat the same data management element that we have learned. You all don't have to follow exactly as per this. That's why I gave you all the reference file here. You can look at the reference file because otherwise you will squint too much onto the screen. You just understand the flow from what I'm doing now, but all the connections you reference from the canvas file. Okay. Now we need to merge all of these values together. Merge. So I will start off with my mesh, my edge length, then my load, and finally my anchor. Okay. And the important thing is we have to flatten all of this information. You can see here they are all in different data structures, which is what we talked about in the early part of this morning. So I'm going to right click, I flatten, right click, flatten, right click, flatten, right click, and flatten. Okay. So I flatten all of this information. Okay, it has all of these goals. You have a locator, you have the spring, you have the anchor. Then you will use the kangaroo bouncy solver. Okay. And you connect this to the goal objects. Oops. Why? And then you will have a toggle, right? Whether to turn it on or off. And then you have a button, button, whether you want to reset or not. Okay, I'll click it to true, and then I can reset it. Okay, it's there. Wait, let me just okay. Okay, so this is too much, right? Okay, so there's too much force. I can always go back and change my force. This one is like your grandma underwear. Okay, you can adjust this. Okay, then become like that. Okay, something like this. So looks more, looks better. Okay, and with this, so that's the cool thing about having it as a computational model, right? I can apply different kind of forces. I can make it go down. I can immediately make it go up. Whoa. Like this. And then I can move my point around. So for example, your design studio, right? Your studio master say, hey, cannot make sense. Put here. Okay, then you put here. My entrance, I want to change my entrance to here. Okay, I change for you. Instantaneous result. You can also add more points, up to you. Okay, and it will update itself. Okay. So click on the button and you will reset. You can play around with the length factors, right? If you reduce the length factor, you see what will happen. You will be more rigid. You increase, you will be more relaxed. Okay. So this is a quick way to do what do you call it? Form finding exercises. Okay. A lot of your professors will say that this is just form finding. Yes. Why? You have question? Or TA? TA? The lady in blue. Okay. So, okay, in summary, right, what we have just shown you for this part of the lesson is a form finding exercise. Okay, we are simulating a physics engine. Okay, this is not a structural calculation, right? This is just simulating forces, simple forces. We will come to structural analysis in week 10. Okay, and we will combine that with an optimization solver. Okay, in week 10. Okay, next week I will also introduce to your assignment 2. Okay, which will be due at a discuss date. You all also can feedback to your TAs today, later on, about your ideal submission date for assignment 2. Okay, so for the exercise today, right, essentially, you can choose to do it with the Esplanade tutorial, which is shown here, or you can do it through this kangaroo thing. There are plenty of information that you can export from here, right? You can export, like, say, for example, the number of members that you have, or you can export the total. This is the one that I've given to you all, right? In which later on, I showed how to make the same thing again. Use the deconstruct VWeb tool to be able to create a diagrid system. And then after that, with that diagrid system, you can have your pipes. You can calculate the number of pipes with the list length command. So you can output that as a CSV file or Conversely, maybe for your exercise, what you can also do is you can, instead of having your points being drawn in Grasshopper like this, you can read from a CSV file where all your anchor points are, right? And then that will go into your Grasshopper file, and then it will determine where the locations of your anchors are. Okay? So there's a lot of flexibility for today's exercise. But as long, so the same way as always, right, I've been trying to tell you all, the exercises are set that the first 4 criteria is giveaway one. If you follow through the lesson, you will definitely get 80%. It's just the final 20% here, the creativity, where it shows whether or not you understand what we are trying to teach you, and you go beyond that, then you'll get the extra 20%. Yeah? Because you see, if you can read or write in your panel, which is what we showed just now, you can set up the CSV file interface, which is you just have a CSV file, and then use dispatch, which means you can do the true and false things that we have just talked about just now. It could be the BWeb, point in BWeb, and then the final one is the use concatenate or split text or merge field, which we have also shown just now. Okay. So in a nutshell, we highly encourage attendance for the lecture as well as the hands-on, because then you will make sure that you can definitely get your 80%, and also when you discuss with your TA, you are more likely to get your 20%, unless you are like a genius, you know. Then you can blow us away with your brilliance. But if you are not so confident, please come and attend the lectures and the hands-on to secure your 100% for your exercise. Okay, any questions for the lecture come hands-on today? Is the pace okay? Can understand? Can all at least complete the kangaroo thing, the point thing? Okay? Okay, very good. The kangaroo thing is actually quite straightforward. As long as you have show, edge length, load, and anchors, flatten all of them, it will definitely work. Okay? It may or may not necessarily be all these points, right? You can, as I said, choose the points in CSV. But the bulk of the lesson and the importance of the lesson is in the data management on top. Okay, because that will help you very much in future for your computational design understanding. Okay, if you all have no further questions, you can take your time to go to your TA portion. As I said today, there's no mandatory submission, but however, just now, if you already taught and finished your exercise and you want to submit, you can also submit. It's open for submission. Insider. Let me double check whether I publish it or not. Oh my gosh. I think so. Yeah, it's here. Oh, there's someone talking. Who is this? Wait. Oh, repeat which part? Where did your mesh come from? Okay. Those here who are confident can go off. Those online, I will show again. Okay. Let me open this and maximize this up.
This one, right? I just do like that. Can you? Oh, you have to apply to.
Okay. From here onwards, delete. Okay.
You have to do something slightly different.
Okay.
The estimate from
I start from this point onwards where we have the rectangle.
What else he wants you to do?
Then we have the mesh plate.
Like this on the explaining tutorial or your
This person
this one is today's tutorial. So you can either generate a new design for
from the sphere onward. Okay. So what I will do to be clean, right? I will just type mesh container. Okay, I will just have a container here so that I can move it around later on. I'll connect this to the deconstruct mesh. Okay, so there is just a connection here so that I can move this around freely later on. The first thing that we need to do now is to get the naked vertices. Okay, so with this mesh connected to the naked vertices, right, I want to isolate the naked points. So I will use a point tool here and get the point. Now I'm going to minimize this and I show you why I did this. So this is why I have the edge points here, all of these points. Are you okay now? For now, up to now? Edge. Okay, from mesh to mesh, and we want to take the naked vertices here. So the naked vertices here, the naked vertices here are corresponding to all of these points here on the outside. On the outside. Do you understand now? Charlotte, do you understand? Okay, so this one is just to use the naked vertices to find all these edge points. Okay. Then what I just did earlier on was I created a point container. I right click and I set multiple points. I will set all the points that I've drawn earlier on. And I press enter. So now all these points in Rhino that I've drawn is contained in this container here. Then I made these points into a sphere. Okay, so these are all the points in this sphere. And I created a radius of 5 meters for the sphere so that it's bigger, right? I want to affect more points on my naked points. Okay. So now what I want to do is I want to test whether or not the point is in the B-web. Right? All these edge points, whether or not they are inside of this sphere. So I will connect my point over here and then my sphere over to the B-web. That's how I will get all of this true and false. So to literally split up the list, I will need to use a dispatch command. Take the list, the original list from the point here, and put it to the pattern here. Right. So to see this, I need to use my point command again to distinguish between this and this. Okay, so these ones are the points affected. Okay, you can see that now it's only affecting one sphere. So I need to right click on this and graph all of the spheres to influence every single point in the B-web of the naked points of all the edge points. Okay, Charlotte can understand here now. So with these points, we will set them as the anchors. Okay. And then my strength will be 75, which you can change later on. I will also need to apply a load to them, right? So all these loads must be connected to all of the points. Okay. So it's to all of the points, not to the edge points, to all of the points. So that has to be from all the vertices. And the force vector is in the z direction because we want it to either to be up or down. And I created a value from negative 0.9 to 0.9. So this will be all the loads. The next thing we need to explain is the edge length. Right, the edge length you will take from the mesh. See this mesh over here. And the length factor, I can put it as 0.15. And finally, as I mentioned, there's always 4 elements minimum. We need to show the mesh at the end of the day. So double click and type show. Again, connect this to the mesh tool. And now you need to merge all this information together. Same as what you have done in your earlier part of the lesson today. So merge all of this info together. And then you need to flatten them because you see here the information is all in different data structures due to the different wires. So you flatten, you flatten, you flatten, and then you flatten again. Then finally, you use your bouncy solver, put in the goal objects, use a toggle to switch on and off your simulation, and a button to reset. So every time you click on the button, it will reset. So for example, now if I click this, it will reset. Right, so I can change this value to be another value. You can see it's doing a different thing, right? I can adjust this and it will flip up. Okay, if you have any further questions, feel free to reach out to the TAs. Yeah, okay, Charlotte, if you still don't understand, feel free to reach out to me via email or MS Teams. Okay. So I will stop sharing now and stop the recording. Anyone who still is not clear, reach out to your TAs or reach out to me directly. Okay? Okay, thank you.